Look at this building. Really look at it. Straight walls, clean edges, no cracks, no smoke, no warning signs. Now imagine something unsettling. Tomorrow morning, this building fails. Not because of fire, not because of impact, not because of age. It fails while looking exactly like this. Here's the question most people get wrong. Where would you expect the problem to be? The concrete, the steel, the height. Almost everyone points upward. History points downward. Some of the most serious building failures ever recorded had nothing to do with the structure people were staring at. They began somewhere else, somewhere invisible. And once that part failed, everything you could see stopped mattering. The most dangerous part of a building is the part you never see. And the reason why is far more uncomfortable than people realize. Here's the illusion that traps almost everyone. We associate strength with visibility. Thick columns look strong. Tall buildings look confident. Solid concrete feels permanent. So when something fails, we search for visible weakness. Cracks, bending, fire damage. But buildings don't fail the way humans judge strength. A building is not a single object. It's a chain. Every load, every kilogram moves downward, always, through slabs, into beams, down columns, into foundations, and then into the ground. That final step is where judgment quietly transfers. The structure doesn't hold the building. It only passes responsibility. The ground decides whether the building gets to exist. Which raises a disturbing question. If the ground is misunderstood, how would anyone know? Pause for a moment. This channel isn't about dramatic collapse clips. It's about understanding why systems fail before anyone reacts. If you care about understanding failure, not just witnessing the aftermath, subscribe now, because everything you're about to hear connects disasters most people think have nothing in common. In 1913, engineers completed one of the largest reinforced concrete grain elevators ever built. Massive, heavily reinforced. By the standards of the time, over-engineered. From the outside, it looked indestructible. Then something happened that confused everyone. The building didn't crack. It didn't tear itself apart. It tipped over, almost intact. That shouldn't be possible, unless the failure wasn't in the structure. The foundation rested on soft clay. Clay doesn't fail dramatically. It compresses, slowly, quietly, almost politely, until one day it reaches a limit. The structure above had done everything right. The ground had not. And once the soil lost bearing capacity, gravity did exactly what gravity always does. Here's the part that should bother you. From the outside, there was no obvious reason to panic, until the moment physics made the decision final. Now ask yourself this carefully. If a building can stand for years on an inadequate foundation, how many buildings today are doing the same thing? And more importantly, how would anyone know? There's no alarm for soil fatigue, no visible countdown. Foundation failure doesn't announce itself. It doesn't warn. It waits. And when it stops waiting, there is no negotiation. This is where most people start to feel uneasy, even if they can't explain why. Everyone knows the Leaning Tower of Pisa. Most people think it leans because it's old. That's wrong. It started leaning while it was still being built. The foundation was shallow. The soil beneath it was soft and compressible. As construction continued, one side of the foundation settled more than the other. The tilt increased with every added layer of weight. Builders tried to correct it by adjusting upper floors, but the failure wasn't above ground. It was already underground. Here's the uncomfortable insight. The tower never stopped failing. It simply failed slowly enough that people mistook survival for safety. Foundation failure doesn't need collapse to be real. Sometimes it lasts for centuries. Stop here for a moment. Think about this question, seriously. If a building is slowly settling, but still standing, is it safe? Or is it just early? Comment your answer. And if this question is bothering you, that's the point. This channel exists to explore failures most people never learn how to question. If this is changing how you think, you'll want the other videos here too. In 2009, a residential building in Shanghai tipped over sideways, almost intact. No material failure, no weak concrete, no poor reinforcement. The problem was nearby excavation. Soil was removed on one side of the foundation. Excavated soil was piled on the other. The balance of the ground changed. Foundations don't negotiate. Once lateral support disappears, rotation begins. And once rotation starts, there is no correction. The structure didn't fail first. The environment did. This is what makes foundation failure so dangerous. The building can be strong. The mistake can be next door. Different countries, different decades, different construction methods, same pattern. Rushed soil investigations, ignored groundwater behavior, excavation too close to existing foundations, and the most dangerous sentence in construction: it's holding for now. Foundations don't care about for now. They care about limits. And limits don't move because people feel confident. They move only when physics allows them to. This isn't about ignorance. Engineers understand soil is complex. This is about pressure. Cost pressure, schedule pressure. The temptation to trust what worked before. The ground looks quiet, so people treat it as simple. But the ground records every decision, every load, every excavation, every shortcut. And when it responds, it does so without warning. Buildings don't fail randomly. They fail because of choices made underground long before anyone moves in, long before cracks appear, long before danger looks obvious. The most dangerous part of a building is the part you never see. If this video changed how you look at buildings, don't stop here. Watch the other videos on this channel. Each one reveals how systems fail before the moment everyone reacts. Because by the time failure is visible, it's already too late.